Hello everyone, welcome to my channel proChem Academy. In this video, I will discuss the next topic of acid-base salt of class 10 book of ICSE. Now in previous video, we have already discussed about the reactions of acid and bases and their preparations and their properties, how we can prepare, and the concept of Arrhenius theories also. Now today I will discuss about the neutralization reaction. Okay. Acid-base salt neutralization reaction from class 10 ICSE. Okay. Now also we discuss how we can compare, how we can know about the strength of an acid or strength of an base, strength of an acid and strength of a base, how we can know about strength. Okay, that is pH scale. So today's discussion will be on the neutralization reaction and pH scale. Now what is neutralization reaction? The reaction in which equimolar of acid and base reacts together to form salt and water. That means hydronium ion or H plus ion of an acid and OH minus ion, that is hydroxyl ion from a base, reacts together to form salt and water. That reaction is called neutralization reaction. Okay, so the reaction in which hydronium ion, that is H plus from an acid and OH minus, okay, hydroxyl ion from a base reacts together, base, okay, reacts together or join together to form salt and water. Okay. Example, say HCl is an acid, it will form H plus and Cl minus in aqueous solution obviously, plus one base, sodium hydroxide, aqueous solution. Now what will form? This Na will combine with this Cl to form NaCl and H with OH to form H2. So this is the neutralization reaction. Okay. Now from here it is clear that acid and base will react together to form a salt and water. That time the reaction will be neutral. Okay, that means same molar of acid will react to it, same molar of base to form salt and water. Okay, now here in this case, for this reaction, the amount of heat released for this neutralization reaction, okay, the amount of heat released to react 1 gram mole amount of acid with 1 gram mole amount of base. Okay, that means the total heat, amount of heat released to neutralize equimolar of HCl with sodium hydroxide to form salt and water. It is called the neutralization reaction. Okay, and in this neutralization reaction, the amount of heat released, it will be the heat of neutralization. Heat of neutralization. Heat of neutralization. What is that? The amount of heat released. Amount of heat released to completely neutralize 1 gram mole of acid by base. Okay, so it is the heat of neutralization. Okay, and from here we know about the strength of the acid base reaction, strength of acid and base. Okay, so copy this one. After that we will discuss the strength. Okay, okay, so I'm erasing this one. Okay, now here we can take 1 gram equivalent also. 1 gram equivalent also you can take. Okay, instead of this you can take also 1 gram equivalent, that is the amount of heat released to complete neutralize of 1 gram equivalent of acid by base. Okay. Now we discuss the pH scale. pH scale, that means the method by which the strength of an acid we can calculate. pH scale. pH scale. Okay, so strength of an acid is calculated by the pH scale. Okay, now strength of an acid or base depends upon the H plus ion concentration. Okay, depends upon the H plus ion concentration. Now normally in neutral water, the concentration of H plus ion and OH minus ion are same. In neutral water, the concentration of H plus and OH minus ion are same. Okay, next point we are writing the concentration of H plus and OH minus ion in neutral water are same. Okay, now what is the concentration of H plus and OH minus ion in neutral water? Okay, the value of concentration of H plus or OH minus as it is same ion in neutral water is 10 to the power minus 7 mole per liter. 7 mole per liter. Now the product of the concentration of H plus and OH minus, the product of this is concentration symbol when we are giving a square bracket. Concentration of H plus and OH minus ion, the product of concentration of H plus and OH minus ion is called ionic product. Is called ionic product and it is denoted as Kw. Now Kw will be here. Kw equal H plus ion concentration, it is 10 to the power minus 7 and OH minus also 10 to the power minus 7. So we will get 10 to the power minus 14. So it is Kw and it is constant for a neutral water. This value of ionic product is constant. It will not change. Okay. So copy this one first. Okay. Copy it. Now we will see. Okay. So what I am telling that this will be constant. This Kw is constant. It will be minus 14 at 25 degree centigrade temperature. Now in this Kw, if you add some acid, then the concentration of H plus ion will increase. Okay, and if you add some base also here, then the concentration of OH minus ion will also increase. But the overall Kw will be constant. Okay, overall Kw will be constant. So to sum up, we can take three conditions that if H plus ion concentration is equal to OH minus ion concentration, then the solution will be neutral. Okay, solution is neutral. Next, if H plus ion concentration is greater than OH minus ion concentration, the solution is acidic. The solution is acidic. If H plus ion concentration is less than OH minus ion concentration, solution is basic. So from here actually the strength of H plus ion concentration depicts the solution is neutral or acidic or basic. Okay, this H plus ion concentration actually depicts the solution is neutral or acidic or basic. That's why the strength of a solution, that is it is acidic or basic or neutral, it is calculated from the H plus ion concentration. Okay, from the H plus ion concentration. Okay, so for this, as the H plus ion concentration is actually depicts the strength of a solution, That's why after that in 1909 scientist Sorenson was given one theory that actually tells us about the how to calculate the strength of an acid or base, and that is only depend on the strength of H plus. Okay, and that is called pH scale. That is called pH scale. Now P here, P what denotes potential, that means power, and here H denotes hydrogen, that means the power of hydrogen ion, power of H plus ion, that is the pH. Okay, so pH will be calculated. We will calculate the pH on the basis of H plus ion concentration, and we will say that this one is acid or base or neutral. Okay, normally if a solution having pH, we have a pH scale like this. If the pH of the solution is 7, it will be neutral. The solution will be neutral, not acidic nor basic. If the pH is more than 7, like that, it will be basic. So basicity increases from 7. Okay, and if the pH is less than 7, the solution will be acidic. The solution will be acidic. So acidic property increases from this only. Okay. Now pH can be calculated. So we can easily know from the pH value which solution is neutral, which solution is acidic, which solution is basic. Simple. Now we can calculate pH, value of the pH of a particular concentration of a solution from this formula. pH equal negative logarithm of concentration of H plus. So actually pH is this one, negative logarithm of concentration of H plus. Okay, negative logarithm with base 10 concentration of H plus. Okay, concentration of H plus. Now if anybody asks you calculate the pH of a 10 to the power minus 3 molar HCl solution, calculate. What we will do here, this 10 to the power minus 3 means H plus 1 concentration. So we know what are the formulas of log. So pH equal minus log base 10, this concentration symbol here I will put 10 to the power minus 3. So this minus will come in front, so minus plus 3 log 10 to the base 10. Now we know log 10 to the base 10 or log a base a is 1, so it is 3. So like that you can calculate the pH. Okay, so today is done. So next day we will discuss about the reactions or the classifications of acids and bases, which is not done. Next day we will discuss. Strength is already done, and about the indicators and titration we will discuss. So today's video is up to this. If you like this video, then do like, comment and subscribe my channel so that I can make more videos that will motivate me. And if you not hit the bell icon, then please hit the bell icon so that whenever I upload the video, you will get the notification. Thank you.